Hi, hope you're having a great day. In this video, we will create a simple Kafka Streams application. What will this Kafka Streams application do? So basically, the input to this Kafka Streams application will be a stream of video data. This will contain information on the number of views each video is getting. The Kafka Streams application in turn will be aggregating all the view data and giving us the total view count per video. Now, let's get started with this. The first thing that we need to do is install Kafka. I am currently in the Kafka page. Let me go to the downloads option. I'll be downloading Kafka version 2.8.0. Let me click on this. I'll go to a terminal. I'll be using the wget command. This will take a while to download. Let's wait for it. Now let us extract it. The next thing that we need to do is we need to start Zookeeper in Kafka. Let me get into the Kafka folder. The way we start Zookeeper is with the following command: bin/zookeeper server start.sh. We will run this in the daemon mode. config/zookeeper.properties. This will start the Zookeeper. The next thing we need to start is the Kafka broker. We will start it using the following command: bin/Kafka server start. We'll start it in daemon mode. config/server.properties. Let us verify if everything is started. You can use ps-ef grep Kafka. We can see that the Kafka and Zookeeper processes are started. The next thing that we need to do is create the topics. We will create an input topic from which the Kafka Streams application will read, and we'll also create an output topic where the Kafka Streams application will write to. This is the Kafka topics command, which will help us create the topic. So we have created the input topic. Similar to this, we can create the output topic. It's the exact same command. I'll just change the topic name here. The topic is ready. The next thing we need to do is create the actual Kafka Streams application. Let me open my IDE. We will create a new Maven project. I'll name it as Kafka Streams YouTube demo. Now we have the base project created. The first thing that we need to do is add the Kafka Streams POM dependencies into this pom.xml file. So in order to simplify this, I have already pushed the code to GitHub. So let me open that. So I'll put a link to this particular GitHub repo in the description below as well. So what we'll do is we'll just copy the dependencies directly from here. Let me copy this complete thing. I will paste it here. Now what you'll see here is two main dependencies added. One dependency is for Kafka Streams. We are using the version 2.8.0 of Kafka Streams. Another is for logging, the SL4j library. We are also telling that we want to use Java 1.8. That's the reason you see this compiler plugin here. As well as we have the Maven assembly plugin. This will help us in creating a Uber jar. An Uber jar is basically a jar which has all the dependencies present in it. That way, it will be very easy for us to run the complete Kafka Streams application. Now, let's get started with the actual code which we have to write. So I'll go to source main Java. Let me create the class here. I'll call it as Kafka Streams demo. So we have our Java class here. Now let's get started with the implementation. First, I'll create a main function. The next thing that we'll do is we'll set up a basic log configurator. So one thing which we have to do in POM is hit this refresh button so that all the dependencies are coming in properly. That way we won't get any errors in this Kafka Streams demo. Now let me import this. Next, we'll set the default log level to info. The next thing is we need to add a bunch of surveys. So in this case, in case of Kafka, we'll be sending string and long. Basically, we'll be sending the video name, which will be a string, and the count for each of the videos, which is nothing but the view count, will be a long. So we'll have two surveys, one for string and one for long. This survey in turn will help the Kafka Streams application read and write data to the Kafka topic. This is the string survey. Next, we'll have the long survey. The next thing is we need to create a Kafka Streams builder. So I'll create a Streams builder. Let me import this. Next, we'll create the actual case stream where we will read the data from the input topic. So I'll create a case stream, key string. The value is a string as well. Views. Let me import this. We'll say that we want to read from input topic. And here we need to put the surveys we want to consume with. So in this case, both the key and value will be a string. Next, we'll create a K table, and this is where we'll be doing the aggregation. We'll be counting per video what is the view count. So the key is a string, which is nothing but the video name. The value is a long, which is the view count. Let me call this total views. On the input topic stream, let us run the following. First, I will map the values. So what we'll do is when we are sending the data to the input topic, the view count will actually be a string. So first we'll have to convert the view count itself to a long. So I'm doing a long.parseLong. Let me import ktable. Next, we need to do a group by. So we need to say the survey for the group by. So I will put grouped dot width. Here I'll put string survey, which is our key, and long survey, which is for the count. Finally, I'll put a reduce operator. This is the one which will actually do the counts. And we are using a sum operator since we just want to find for any video what is the total view count. The reason we are using this group.width is to ensure that the aggregated data can be stored properly in an internal Kafka topic which Kafka Streams will maintain. Next, we need to write this total views data back into the output Kafka topic. Let us do that now. Total views dot toStream dot to. Here we need to put the output topic. We need to say the surveys we want to produce with. I'm doing produce.width. Key is string. Value is a long. The next thing that we need to do is indicate which Kafka cluster are we dealing with. Here we have just a single Kafka broker which is running in localhost port 1992. So let us point to that. So first I'll create a properties. Next, let us put a name for the application. You can put any name you want. Application ID config. I'll just call this as streams total views. Here we need to put the broker details. Finally, we need to create the actual Kafka streams. So till now we have just created the topology, but now we'll create the actual Kafka streams. So here I'll give Kafka streams builder.build. Basically, builder is nothing but the streams builder. We are building that. That will build the topology. And we are pointing it to the properties, which is nothing but your Kafka details and the Kafka streams application name. Finally, we need to start the stream. So you can use streams.start. Now, if we run the application as is, it will work. But one challenge here is if you shut down the application, it will not shut down properly. So we need to have a proper mechanism to handle shutdown as well. Let me add that now. So basically here we are starting it within a try catch, and if at all any exception comes, we are exiting with the status code 1. We also need to add a shutdown hook. So if at all any shutdown happens, then it'll go to the shutdown hook. Let me create that. So here in the shutdown hook, we are saying that first close the stream and then do last.countdown. Then finally, we do a system.exit. The way the system works is as follows. Whenever you try to shut down the application, it will go to the shutdown hook. The shutdown hook will ensure that your streams is closed. Then it will do a latch.countdown. Here we have given the latch size as 1, which means when you do a countdown, the count will go to 0. And the moment the count goes to 0, this latch.await will open up. So by default, what would happen is you start the stream and you're waiting at this latch.await. But when it goes to 0, this will open up. And finally, your code will go to system.exit of 0, which means you have exit from the code. If at all any exception comes, then it'll go to the catch block and it'll exit with the status code 1. So this completes the complete application. The next thing that we need to do is package this application and then run it. For that, let me go to Maven here. I'll go to lifecycle and click on package. Let us wait for it to package. The packaging is complete. In target, now you can see this jar with dependencies. We need to run this jar. Let me run that. Let us open up a terminal and run this application now. I'm opening the terminal. So the command will be java jar. I need to put the location. The project name is Kafka Streams YouTube demo. And let me copy the jar as is. .jar. This will start running the Kafka Streams application. Now we can start producing messages to the input topic and consuming the output from the output topic. Let me open up 2 more terminals. Let me shrink the other terminal so that it fits in screen. So what I'll do is in the left hand side terminal, I will be producing messages, and in the right hand side terminal, we will see the Kafka Streams output. So for that, first I have to start a producer here and a consumer here. Let me do that. So here I'll start a producer. It will be bin slash Kafka console producer.sh. Bootstrap server is localhost 1992. Topic, input topic. Then since we are sending both key and value, I need to give a separator. I'll give it as colon. Key dot separator. Also, we need to say that we are passing a key. Parse.key is equal to true. So this will be our producer. Let me also start a consumer. Let me go into the Kafka folder. I made a mistake in typing localhost. Let me type it properly. Here let me put a console consumer. Topic is output topic. I'm saying that we want to print the key. Key dot separator, we'll use a hyphen. Next, we need to say a deserializer. Let me put that here as well. So this is the key deserializer, which will be a string. Next, we need to put a value deserializer. Let me put the console consumer. Now we can start sending some messages. Let us see how the output comes. I think this video 1:5 will not come since that was not written to producer. You can see that video 2 10 came here. I'm sending now video 1, the view count is 4. That will come here as well. Now let us try some aggregation. I'll send video 2 as say 20. And I'll send one more video 1 with something like 8. Let us see if it is aggregating. You can see that it did aggregate. So now it's saying that video 2 is 30. That is because here video 2 was initially 10, then we sent a 20. So it has aggregated and sent it to 30. Similarly, in video 1, we have sent a 4, then we sent a 8. So in total, it is saying that video 1 value is 12. Maybe we can send more values as well. So let me send video 2 as something like 50. I'll send a video 3 as well with 9. And I'll send video 3 again with 4. As you can see, now video 2 is 80. That's because we sent one more 50. And video 3 is 30, which is the sum of 9 plus 4. I hope that now you understood how to create a Kafka Streams application. If you want to see more videos like this, then hit the subscribe button below as well as hit the bell icon. Thanks for watching.